Alright, the first part of this lesson, well, actually second, third parts, are going to refer to a handout that I've sent you in your email. If you don't have that yet, you might want to pause this and go look in your email and see if you can print this out. For those of you that have been with us before in previous terms, it will be very similar to the handout that we've done before on graphing lines. But on this first part, we're talking about graphing by plotting points. And what I want you to know is that you have to have an equation, and then you select x values, whatever x values seem to make you happy. I'm going to use I can't use anything very negative because it's not going to fit, but let's just say if I chose -1 and maybe 0 and +1 and +2 and +3. Now some of those are going to fit on my graph and some are not. But what I do is I get to pick the x values and I substitute them into the equation. So 5 times -1 minus 10 is a -15. And 5 times 0 minus 10 is -10. And 5 times 1 minus 10 is -5. 5 times 2 minus 10 is 0. And 5 times 3 minus 10 is +5. Now I'm going to plot those points over here on my graph. So -1, -15 won't fit. But 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 is right here at the bottom. And 1, 1, 2, 3, 4, -5 is here. 2, 0 is right there. 3, 1, 2, 3, 1, 2, 3, 4, 5. And what you should see is that those points should lie on a straight line. If they don't, and it was something of this form, then you've made a mistake somewhere because they're supposed to lie on a straight line. I'm looking for something that's a straight edge to show you. Hold on, here we go. So you can see how they all line up, and so you connect the points. And that's how you graph by plotting points. Now, if the equation is something like this, y equals mx plus b, you'll remember from past days that that's going to be a straight line. If, excuse me, if the equation has an x squared in it, it's going to be what we call a parabola. And it might be a parabola that opens up, it might be a parabola that opens down. But if it's got an x squared in it, you're going to need to plot enough points until you find that shape. Whenever you do this on my math lab, it doesn't allow you to plot all these different points. And so what you do for a line, on the graphing, you remember up in the right corner, there's a toolbox that lets you pick which one you want to do. And so you would pick that you're going to do the line, and you would click on any one point and then click on a second point, and it draws the line for you and you're through. So on my math lab, you only do it with 2 points, although if you were doing a test, I would do multiple points just to make sure that you haven't made a mistake, to make sure that they actually line up. Alright, so on x-intercepts, we've talked about that before, perhaps you remember that. The x-intercept of a line is the point where the line crosses the x-axis. To find it, we let y equals 0 and solve for x. And then the reverse is true. The y-intercept of a line is the point where the line crosses the y-axis. to find it, we let x be 0 and solve for y. Now in both of these it says line because that was what we were primarily concerned with, but it applies to every kind of equation that there is. So those are the concepts that we're going to use at least in part of the first part of the homework. Alright, so now I'm going to the homework, which is on page 166. Alright, focus with me here now. Quit doing that funny stuff. What is it focusing on? There, that's better. Alright, the first group of problems in this, we're starting with number 13. It gives us an equation, and the question is, do these points that are listed satisfy this equation? That is, if we were to draw the graph, would these points be on that graph? Okay, so the points are, for this problem, 0, 0, 1, 1, and 2, 4. So what you do is substitute in the x value into the equation. Well, 0 to the 4th is just 0. And the square root of 0 is 0, and 0 minus 0 is 0. If you get the y value that they had listed here, then yes, it's a point. Alright, so let's do this one. 1 to the 4th minus the square root of 1. Well, 1 to the 4th power is 1, and the square root of 1 is 1, and 1 minus 1 is 0. Well, that's not what this y value says. So for this one, it would not be a point. Let's try 2, 4. So it'd be 2 to the 4th power minus the square root of 4. Well, 2 to the 4th, 2 multiplied 4 times is 16. And the square root of 4 is 2. And 16 minus 2 is 14. It's not 4, which is what they had listed. So this one is not a point. So of the 3 points they gave me in number 13, only the first one actually satisfies the equation. Alright, I'm going to skip on down to number 15. And I'm going to show you an alternate way to do it than the way I just did. You can substitute in both x and y and see if you get a true statement in the end. So that's what I'm going to try on this problem. I'm going to put in 3 for the y. So that's an equal sign right there. And I'm going to put in 0 for the x. And copy the plus 9. 3 squared is 9. 0 plus 9. If you get a true statement right here, whoops, you can't see that, can you? 0 equals 0, 9 equals 9 rather, then that means yes, it would, the point work. This one actually is a point on this graph. Alright, so I'm going to try this one. So I fill in the 3 for the x and the 0 for the y. So that 0 equals 9 plus 9. Well, you know 0 doesn't equal 18, so that one is not a point on the graph. Alright, let's try this one. Put in 0 for the y. Put in negative 3 for the x. Negative 3 squared is still a positive 9, so I still get that, so no, that one's not a point. So of these, this is the only one, 0, 3 is the only one that's part of this equation. So there are two ways you can do it. You can substitute in and see if you get the y value they give you. If there's a y squared involved, then it's probably easier to substitute both the x and the y and then see if you get a true statement in the end. So that's the first kind of problems that they're going to deal with. You're going to deal with in the homework. All right, now we're moving on to problem number 21. Same page, and it gives me y equals 2x plus 8, and the instructions are to find the intercept and to graph by plotting points. So this is going to be the two things that we were just talking about a minute ago on that handout. We're going to find the intercepts by letting x be 0 and solving for y, and letting y be 0 and solving for x. I'm sorry, I don't know why this thing won't stay in focus. It's focusing on something else that I can't find what it is. Okay, so here we go. I'm going to put in 0 for the x, and solve for the y. And that gives me my y-intercept. Okay. Now I'm going to put in 0 for the x. I just did that back. Crud. That was the y-intercept. Okay, strike that. Now I'm going to put in 0 for the y. That's what I was trying to say. And we have to solve for x. So we're going to subtract 8. Then we're going to divide by 2, and so I get -4. Now, on my math lab, because you only need 2 points, you can do it with just those 2. So what you would do is go to the graph, and you would tell it that you want to do a line, and then you would go to the point 0, 8, 1, 2, 3, 4, 5, 6, 7, 8, right here. And then you'd click, and then you go to the point -4, 0, 1, 2, 3, 4, and click there, and the computer will draw the line for you. And that's all you have to do with that one. Okay? So, the next one is y equals x squared minus 1. And it told me to find the intercepts. So I'm going to start with letting x be 0. And that's going to give me my y-intercept, which is -1. Then I'm going to let y be 0, and I got to solve for x. So I'm going to add the 1 to both sides, and then I'm going to take the square root of both sides. We learned that we could do that, and you always get plus or minus, and the square root of 1 is 1, and so I get positive and -1. That means I have 2 points, 1, 0, and -1, 0. Okay? So when I go to graph, I have to choose that I want to do a parabola. Remember I told you earlier that if there's an x squared, it's going to be a parabola. So I have to tell the graph that I want to do a parabola. And then I think you can, I'm not positive about this, but I believe you click on 0, -1, and then click on 1, 0, and think, I don't know if you have to click on this point or not. Sometimes it does it automatically, but that's what you want your graph to look like. So I may have to look that up and send you some more instructions about how to do a y-squared. Okay. I don't think I told you that that was number 23. I'm sorry. Okay. Now, I want to go to number 25 because I want to caution you about this. When you substitute a number for x, you're going to square it and then take the opposite of it. Of course, since we're doing 0, it won't be that big of a deal. All right, when we put in 0 for x, zero squared is 0, and then minus 0 is still 0, plus 4 is 4. Now, when I put in the 0 for y, I'm going to subtract 4. Then I'm going to multiply both sides by -1 because I can't take the square root of a negative. So I multiply both sides by -1. Now I can take the square root and I get positive and -2. So that means I have 2 points, 2, 0, and -2, 0. And again, it's going to be a parabola, and I'll graph the point 0, 4, and then the point 2, 0, and the point -2, 0. And this time my parabola is going to open upside down like that. Alright, the next group of problems that starts with number 31 is just a matter of plotting points. And I think y'all are familiar with that. I don't think we really need to talk about how do you plot points. If you aren't sure, then you need to Google how to graph points on a rectangular coordinate plane. So that group of problems should be okay. Then we go next to problem number, oh, I'm sorry. I am so sorry. I did not read all the directions. Let me just back right on up. All right. It always helps to read the directions. I'm on problem number 31. And it gives me the point 3, 4, but it tells me more than just to graph it. It tells me to graph it and then to graph another point that's symmetric to the x-axis, the y-axis, and the origin. Alright, so that brings us to the point that we need to talk about what symmetry means. Well, symmetry in general means it's a mirror image. See, this butterfly is symmetric because I can draw a line down the middle and one side matches the other. Alright, when a graph is symmetric to the x-axis, I'm on page 162 in your book, it matches itself across the x-axis. In other words, if you fold it across the x-axis, it's going to be the same image. Well, the way you do that, if you have a point, you keep the same x and change the y. Change the sign of the y. Okay? Now, to be symmetric with the y-axis means if you fold it across the y-axis, in this case fold it like a hot dog bun, you're going to get a mirror image. And the way you do the point there is to get, if you have a point, you change the sign of the x-coordinate. Okay, so let's remind ourselves. When it's x-axis, you change the sign of the y-coordinate. When it's y-axis, you change the sign of the x-coordinate. Alright, and then there's one called symmetric with respect to the origin. And I've lost my next page, 163. Okay, it doesn't really show you a picture of that. I'll show you one right here. It's on page 164. This is symmetric with respect to the origin. It means that if you fold it across here and fold it across here, that it matches itself. So that's called respect with respect to the origin. If you do two folds and it matches itself. Here's one that is symmetric with respect to the origin. If you consider only this part right here, if you fold it across the Y and then fold it across the X, it'll land on top of this one. And that's what it means to be symmetric with respect to the origin. Alright, so how do we get the point when we have it symmetric with respect to the origin? And they don't tell us that. I was looking in the book, and so I will tell you. If you have the point XY and you want it symmetric with respect to the origin, you change the X and the Y. Okay? Alright, so that's what symmetry means. It's finding a matching point. So back over here on problem number 31 that had the point 3, 4, I'm going to go to a graph and try to get it in focus. I don't know why this thing keeps doing that. Okay, so I'm going to graph the point 3, 4. Starting, this is my 0, 0. 1, 2, 3, 1, 2, 3, 4. That's my original point. Alright, the problem told me to part A, graph it with respect to symmetry with the x-axis. So I want to flip it over the x-axis. That means I change the sign of the y. So I'm going to graph the point 3, negative 4. 1, 2, 3, 1, 2, 3, 4. So 3, negative 4, that one has x-axis symmetry. Alright, now I'm going to go back to my original point, and it says do y-axis symmetry. That means you change the sign of the x. So I need to do negative 3, 4. 1, 2, 3, 1, 2, 3, 4. Okay, so that's my y-axis symmetry point. And then it tells me to do the origin. Well, that means I change the sign of both of them. So I'm going to make it negative 3 and negative 4. 1, 2, 3, 1, 2, 3, 4. And there's my origin point. Okay, so that's what you're going to do in that group of problems. Let me review. Given a point, to find the one across the x-axis, you change the sign of the y-coordinate. To find the one across the y-axis, you change the sign of the x-coordinate. To find the one that's symmetric through the origin, you change the sign of both of them. Okay, so that actually reading the directions, that's what that says for that group of problems. Now, the next problems that we're going to look at start with problem number 57. And it gives me the equation y squared equals x plus 16. And it tells me to list the intercepts and to test for symmetry. Well, I can do the intercepts like I've been doing. So I'm going to put in 0 for x, and I get the 0 for x right here. I get y squared equals 16. So that means y is both positive and negative 4. Plus or minus 4. That's actually 2 points, 0, 4, and 0, negative 4. Then I'm going to put in a 0 for the y. Zero squared is still 0. Then I'm going to subtract the 16 to solve for x, and that gives me that point. Now, if you look in the book, it tells you to test for symmetry, to replace y with negative y and replace x with negative x. Well, I'm going to suggest to you a little bit easier way. What I'm going to suggest to you is take your equation, pick some number for x, any number. It's better not to use 0 and 1, so I'm going to choose 3. And I get y squared equals 3 plus 16, so y squared equals 19, and y would be positive and negative square root of 19. Okay? Now, I want you to pick the opposite number for x. So this time I'm going to use negative 3, and I'm going to put that in for x. Negative 3 plus 16 is 13. And so I get y equals plus or minus the square root of 13. Okay. If I don't get the same number here, when I use different signs for the x, that tells me it does not have y-axis symmetry. So switching the signs for x is testing for y. No y-axis symmetry. Whoops, you can't see that. There it is. No y-axis symmetry. Alright, now I'm going to do the same thing, but this time I'm going to put in a value for y. I'm going to say let y be 5. So I get 5 squared equals x plus 16 and I get 9 equals x. Now I'm going to use the opposite value, and negative 5 squared, remember, should still be a positive number even when you square a negative. And I got the same value. You can't see that. When I used 5, I got 9. When I used negative 5, I got 9. Okay, so when I change the signs of the y and I got the same value for the x, that tells me it has x-axis symmetry. Alright, another thing they don't tell you in the book is no graph can have only 2 of the 3 symmetries. It either has none, 1, or all 3. Okay? Let's look at that. None of the 3, only 1, or all 3. Well, that problem I was just looking at, this problem right here, I determined that it does not have y-axis, but does have x-axis. Well, if it has x-axis and doesn't have y-axis, there's not an option for it also having origin, because it's either 1 or all 3. So the fact that it doesn't have y means I don't have to do the test for the x. Okay? Now, the only time that you'll actually have to test for origin symmetry is if the answer is no to x-axis and no to y-axis. Then you would have to test it for origin. Okay, so I'm going to look at problem number 59. Y equals the cube root of x. So to test for y-axis, I choose a number for x, and since I'm doing cube root, I'm going to choose something I can take the cube root of. Then I'm going to choose the opposite of that. If I get the same answer, then the answer is yes to y-axis symmetry. Okay? So this is y equals the cube root of 8. So y would be 2. This is y equals the cube root of negative 8. And y would be negative 2. I don't get the same answer, so it's no for y-axis. Remember, when you change the sign of the x, you're testing for y. Alright, now I'm going to put in a number for y. And I'm going to put in 3. I'm going to let y be 3. Well, to solve for that, I have to raise both sides to the third power. And I get x is 27. Now I'm going to put in the negative number for y. And I have to raise both sides to the third power. And I get negative 27 equals x. Well, I didn't get the same sign. So that tells me no. I changed the y, so I was testing for x. Okay? So I have no y and no x. That means I have to check for origin. And to do origin, you pick either an x or a y, and if you get the opposite, then that means it has origin. Well, look what happened. When I put in an x, I got 2. When I put in negative 8, I got negative 2. I got the opposite answer. Look what happened over here with the y. When I put in 3, I got 27. When I put in negative 3, I got negative 27. So the fact that I can change the y and get the opposite, change the x and get the opposite y, or change the y and get the opposite x, that tells me yes to origin. Okay? Now, in fact, I happen to know what this graph looks like, and it looks something like that. So you can see that it has that origin symmetry there. But it's not a given that just because it has no x and no y, it's not a given that it has origin. Because remember, one of the choices was that it might not have any symmetries. The reason this is important to us is if we know what kind of symmetry it has, then it allows us to graph the graph by matching some points without having to plot as many points. Alright, the last part of this is two what I call parent functions, special functions. One is y equals x cubed, and one is y equals the square root of x. Those are two graphs that if you were going farther in mathematics, you would be expected to just know what that graph looks like because it's used so many times. So what you will do is plot points. Alright, so I'm going to start with negative 3, and I'm going to go all the way to positive 3. I'm substituting in the x and finding the y to go with it. Well, let's look at what that graph would look like. Negative 3, negative 27 is not going to fit on my graph paper. So I don't worry about graphing that one. But negative 2, negative 8 might be about right here. -1 is here, 0, 0, then 1, 1, and then 2, +8, and 327 won't work either. So I get a graph that looks like this. And that is the graph of y equals x cubed. That's a graph that you should recognize as being the cubic function. Now to do the square root of x, since we can't take the square root of negative numbers, we'll start with 0. And I'm going to choose some numbers that I either know the square root of or it's easy to do. The square root of 0 is 0. The square root of 1 is 1. Square root of 2, it happens to be something like 1.4. The square root of 4 is 2, and the square root of 9 is 3. So when you look at those points, and it'd be better if I was using graph paper, but, well, why don't I just use graph paper? Do I have a piece right here? Yes, I do. Okay, so here we are. Let's see if I can get all this on there. Okay, I'm going to graph the point 0, 0, and then I'm going to graph 1, 1, and 2, 1.4, that's like there, and then 1, 2, 3, 4, 1, 2, 5, 6, 7, 8, 9, 1, 2, 3. And so it goes like this. Now notice I put an arrow here, but I don't put an arrow here because it can't go to the left because we can't take the square root of negative numbers. So it starts here and goes to the right. And that's the one that's in the book. That one's number 75. Okay, the last problem in this group is number 79. Where's my graph? There it is. Number 79. And it tells me if I have the point 1, +2, and it is symmetric to the origin, what other point is there? This was 1, 2. Remember, to do origin, you're going to change the signs of both of them. So it would be -1, -2. -1, -2. So that's what you would type in as the other point that would be on the graph. Alright, I know that was long, but there was a lot going on there. So that's the end of this video. See you later.